Hi, welcome back to Moose and Chemistry. This is Common Polyatomic Ions Lesson 1. Right, so what are polyatomic ions? Well, let's look at one here. Let's try SO4. That's a sulfate ion. It's pretty common. So we're going to write SO4 here. And that has a -2 charge. So what does that really mean? Well, sulfur is in group 16, so it's going to have a +6 charge, okay? So we'll put a +6 charge there. Oxygen is in group 16 also, but in this case, it's going to have a -2 charge, right? So we have 4 of these oxygens, and why is it -2 even though it's in group 16? Because this is taking the anion position. So the anion is always going to be negative, right? So let's go ahead and erase that real quickly here, and let's take care of that. All right, so let's make this a little bit bigger. So we know that sulfur is a +6 charge. So we'll make this bigger here. So there's our +6. And we know that oxygen is a -2. All right. So let's give ourselves lots of space here. Let's clear this out here. So now we have a 4 here. So 4 times -2 is -8. And this is a +6. So 6 minus 8 is going to give me -2. That's why this has an overall charge right here of -2. Okay, pretty simple. Let's try a few other constants with this, okay? And then we're going to put these together into a compound. All right, so now let's see. Let's try NO3, okay? So we'll make this NO3. All right, now nitrogen is in group 15, so it normally has a +5 charge. Oxygen has a -2 charge because it's in group 16 and it's in the anion position. So 3 times -2 is -6. So we have +5 here. So 5 minus 6 equals -1. And as you can tell, nitrate right here does have a -1 charge. See how nicely that works out? Let's do one more. Hey, what? Let's look at a positive ion. Let's see how that would work. All right, so we're going to pick ammonia, NH4+. All right, so let's do ammonia, NH4+. Okay, now in this case, nitrogen is in the cation position, so it's going to have a +5 charge. Hydrogen, normally you think hydrogen's in group 1, it has a +1 charge. But when hydrogen is in the anion position, hydrogen is going to contain a negative charge, right? So it's going to be a -1 charge, to be exact. So we're going to say hydrogen is going to be 4 times -1. So this is going to give me 5 minus 4 equals +1. And as you can see, ammonia is a +1 polyatomic ion. Wow. Hey, that was pretty simple. All right, so now enough of that. Let's go ahead and let's take a look at some of these guys and compounds. What do you say? All right, let's try the first one here. We'll do something pretty relatively simple. Let's say KOH, right? So OH ion has a -1 charge, and it's called hydroxide. And potassium has a +1 charge because it's in group 1, right? So now, +1 minus 1 is 0. So this is called potassium hydroxide. Pretty cool. Yeah, it's pretty easy, pretty straightforward. Let's try another one here. Hey, I got one. Let's try this. Let's see. We'll try magnesium hydroxide this time. Let's kind of stay with the same kind of thing here. So we have magnesium, and we have hydroxide ion. There, right? Polyatomic ion. This has a -1 charge. This has a +2 charge. Hey, remember in an earlier lesson we talked about the oxidation numbers in the crisscross dance. So this one's going to come here and -2 is going to go there. So what this is actually going to look like is this. Mg OH2. See that? So you have a -1 charge here and a +2 charge there, and they cancel each other out. Kind of like that? Let's look at another one. Right, let's do one more. What if, in this situation, what if we had, let's go with sodium. And we're going to go with sodium, and we're going to go with carbonate. CO3. That has a -2 charge, and sodium has a +1 charge. Guess what? We're going to do a crisscross here. And when we do, we're going to get Na2CO3. So you have a -2 here, and you have a +1 here. So 2 minus 2 is 0. So that works out great. Listen, you guys be snarly, and we'll see you back here at Missing Chemistry.